So are you a cheap piece of shit like me? Would you rather spend 6 weeks building something you could have bought for $500 or $600, but you decided to hell with it? If I can make it, I'm just going to make it and I'm not going to spend the money? Well, if you're that kind of person, this next series of videos we have coming out is going to be for you. Alright, so what we have here is an old Keller power hacksaw. Now this thing's actually in really good condition. We have a 3-phase motor on here. I could put a single-phase motor on it, but I'm having trouble finding the correct frame. And to be quite honest with you, a single-phase motor would cost me as much for this as it would to buy a little phase converter or something like that. Now, when we built the belt grinder, the 2x72 grinder, I had bought a variable frequency drive that converts my 240 single-phase coming into it, converts it into the 3-phase enough to run that motor. I couldn't do that with this because the motor windings on this thing, the insulation is not heavy enough to handle the voltage spikes that you get with a VFD. Now, if you were to put your multimeter on the load leads of your VFD while your motor's running, you're going to see those voltages going to spike all over the place. And an older motor like this, while they may be tough as nails, I mean they're very tough motors, but an old motor like this is not going to withstand that kind of voltage spikes because it doesn't have a heavy enough insulation on the motor windings. Voltage spikes means you're going to generate more heat in your motor. But if you buy a modern 3-phase motor and it's a certain insulation class, I want to say if it's a F-class insulation or higher, you're good to go with a VFD, but this is not the case. Now this is an extremely fast churning motor. It's 1725 RPM. It's kind of right in the middle of the ground. It can be wired for 208, 230 volt 3-phase or 460 volt 3-phase. So let's start with the particulars here. So this is a 5 horsepower ball door 3-phase motor. It is a 1725 RPM motor. It can either be wired for 230 volt or 480 volt, or 460 volt, excuse me. It is a 184T frame. All that's telling you is the shaft size and the actual motor mounts themselves. And other than that, not much to it. Now this guy here, where's the insulation class on this? Where are you? So this is a Class B motor. This would not be suited for a variable frequency drive. So what we're going to do with this setup, and it's going to become apparent and very clear as we get into it, we're going to take this little 1/4 horse Delta drill press motor I've had kicking around. There's nothing wrong with it, works perfectly fine. We're going to take this motor to turn the shaft on this motor, and that's going to generate a ghost leg of power for us. It's a pretty much that's just a starter motor. Now the neat thing about these, you don't need a lot of power to get this thing going. Once you get it going, that motor actually gets shut off. But what I'm trying to do is I'm trying to match up the RPMs on this motor as close as I can get them with this one. The RPMs on this guy happens to be 1720 RPM, so that's pretty close to this. I'm happy with that. It should be close enough. Now if I need to make up a little more, I left the stepper pulley on there so I can actually change the ratio on this. If I make this a little bigger and this one a little smaller, that'll work just fine for making this turn slightly faster than what this one is. Now I left the motor mounts, I left the bracket right on here that was on the drill press. So that should work quite well for what we're doing for tensioning and whatnot. Now you don't need a lot of tension on this thing either. All it needs to do really is get this thing going enough to generate that 3rd leg of power, and then once you have it spinning, this thing will actually stay running on its own while it's generating that power for whatever you're trying to power it on. Other thing to keep in mind, if you're going to build something like this, make sure that the motor you're using to generate your 3-phase is a 1.5 size at least bigger than the motor you're trying to power. Otherwise, it's just not going to work out. But there's going to be some nuances. We'll get into that. This guy back here we're going to make into a control box for us. This is nice. This is out of an old boiler burner. One of the ones I pulled out last year. So this is on an old boiler burner, and we have a nice terminal strip we can work with. We can keep everything nice and professional, but first things first, we have to build a skid assembly for this and get that part of it worked out, and then we can move on to the wiring. Alright, so before we do anything on this, I want to check the health of this motor because this is an old used motor. I'm going to set my meter to ohms. Now, a lot of people get ohms and continuity confused. If you try continuity, you see you have 0 resistance there. You're going to go down to number 1. That'll tell you if your windings are connected, but that's not going to give you a very accurate reading on what your actual ohms are. Now, these fluke meters actually does a small amount of megohms. I believe it goes up to 50 megohms. It's not a true proper megger, but it uses the battery power of the meter to where you can at least check the ground. Now, if you're picking ground up with this thing through these windings, this motor's no good, so that's something you really want to check. On a 3-phase motor, I want to check all 3 leads, and I already have this set up, rewired for the 230 volt. You have to check your leads together. And they should, all 3 legs should ohm out the same with each other, pretty close to it. If they don't, you have a problem. If you're using these alligator clamp style meter connections, make sure you have good contact with the wire, otherwise it throws it off on you. So we ohm out the same. Now I want to check all 3 legs of this thing to ground. So I want to make sure that I hook this something. Well, I do have a ground screw in here. Let's see if my meter will clamp to it. Okay. Very important, I want all 3 of these. I want to make sure these don't ohm out any reading to ground whatsoever. So I have nothing there. Nothing there. Now granted, it's kind of redundant at that point to check all 3 legs because you know you have continuity in between your legs already, or they ohm out all right. Nothing there. Now here's another thing I want to show you. I see a lot of people do. Let's change our leads to normal ones. The coyotes are going crazy out there tonight. So I see a lot of people when they ohm out wires, they'll take and pinch the wire with their fingers on the leads, like so. And they'll take a reading. Now that's the same reading we had, but here's something, especially when you're checking the ground and you're doing that, your body actually has a little bit of continuity to it. You'll actually have a reading there, so be careful when you're doing that because you can throw everything off just by touching the wires or touching your leads. Well, we have most of it fabricated up. So what we'll hit tomorrow night, we'll start getting this box built, get the electrical panel, start on that. So what we're going to do, I've seen people make these with just the motor sitting on the floor hooked to a piece of wood. I'm not into that, so we wanted something solid, but something we could set on the floor. We're going to make our electrical panel for this a little bit higher. That way the electrical part of this is going to be a whole, it's going to be a whole ball of wax. But what we're after here, as I said, we're going to make a phase converter. This way we can generate the 3-phase power needed to run that power hacksaw that we picked up. Now, I got a hell of a deal on that hacksaw. It was the cost of putting it in my work van and hauling it home. So I'll take that any day of the week. That's a good piece of equipment right there. They are slow, but man, they are accurate. They make nice cuts. And what I'm looking for right now, we're trying to get it to where we can get into good production mode. And part of that for me is cutting a lot of tool steel. And I spend a lot of time on the angle grinder cutting tool steel. Now, we do have a beautiful metal circular saw that Mike Hagdahl sent us. But it doesn't really, it's not made to cut 5/8 inch thick tool steel. That power hacksaw, I can actually get the blades for it for cutting tool steel, and I could really slow the feed rate. So bottom line is, nice to be able to do, get that saw set up, get the piece of metal in it, turn it on, walk away from it, and then I can do other things. I don't care if it takes an hour to cut a piece of metal, because I'm not having to sit there and man it the whole time. Now, it doesn't take that long. It's fairly fast, not as fast as a horizontal bandsaw, but it's still pretty quick compared to me sitting there with a grinder. And like I said, it's a hands-off thing. Once I get it going, I just walk away. But anyway, this is coming out pretty nice. I'm going to have to redo my belt tensioning bolt here. It's seized up in the nuts I welded on, so I guess tomorrow night I will be grinding those off. Maybe I'll try a rod coupling, probably work a little bit better on that than 3 bolts, or 3 nuts, excuse me, getting tired, obviously. So, anyway, that's her. I hope you guys enjoyed this one. I know this video series is probably going to get a little in depth because I'm going to try to explain a lot as I go, because there's not a lot of videos out there on how to do this or how to wire this kind of thing up. Now, that in mind, I'm going to have to throw it out there just to cover my ass liability-wise. Believe it or not, there are people who sue people over YouTube videos. It's one of the dumbest things I've ever heard in my life, but it does happen. Anything you see me here doing, especially with something like this, take it with a grain of salt. Do your own research. If you don't know much about electric motors or electricity in general, how this stuff works, go spend the money and buy a phase converter. I'm the type of person, I am a cheap rat bastard. You know, I don't buy anything if I can make it myself. And this kind of thing, for my knowledge level, it's not beginner, but it's not rocket science either. Worst case scenario, when I get this thing going, I may have to put some capacitors in there to balance the legs of power out. That's worst case scenario. Now keep in mind, with voltage and motors, you're allowed a 10% one way or the other. So I have 240 volts coming into this building. It's good voltage, it's good clean power. If I can get that third leg generated within that 10% one way or the other, so that gives me 20 volts to play with one way or the other. So that's not too bad. But anyway, that's her. I'm going to bed. I don't even think I'm going to edit this one tonight. You guys will probably be seeing this Friday. So thank you for watching, everybody. I hope you enjoyed it. Please stay safe out there. Don't be hacking on each other and all that shit. Public service announcement. And I know for a lot of people things are difficult right now. And it'll get better, folks. Shoot, this country and this world's gotten through a lot worse than this. So try to keep your chin up, and hopefully things go back to normal soon. I'm one of the lucky ones who I'm still working. I'm still getting my 40 hours a week. but there's an awful lot of people who aren't. And I know for me, if people aren't showing up to work, their chances are they're not using their HVAC as hard. So who knows? We'll see how my service calls go, but so far so good. I can tell you this. I used to work for sex, now I work for toilet paper and bread and flour and things like that. So you guys can sleep sound with that thought in your head tonight. Hope somebody gets a mental picture there. And I know Thomas Russell probably already does because he's kind of goofy like that, but we like him anyway. He's a loyal viewer. Good old Thomas. So anyway, have a good night, everybody, and I will see you on the next one.